Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of October 17th, 2022. We got a lot to talk about, so maybe I'll talk even faster than usual. There's a treat for you, and we'll jump right into it. So this week, it's beautiful timing that in the astronomy course, the general astronomy course that we have going on here right now, we've been talking about debris in the solar system. The sort of small bodies of the solar system, and we've been talking about meteors, meteoroids, and meteorites, and the difference between random meteors, random nightly meteors, and meteor showers. And we have a meteor shower coming up this week, and so we have a chance to go out and look at this, and it's the Orionid meteor shower. And so for a meteor shower, recall, we've talked about this before, so I know you remember it, because surely if I say something, you will remember it for all time. For a meteor shower, what happens is a comet boils off material. So when a comet gets close to the sun, it heats up and it releases material, it releases gas. And so you often see that as a tail. In photographs, that will show up as a blue straight tail of material, straight jet of material coming out of the comet, and it looks like a jet. It's being blown by the solar wind, so particles from the sun are hitting that comet and pushing that material away. Now the heavier material, the dust, the grit that's entrained in that comet, we think of the comet as a dirty snowball. It's sort of frozen gases and liquids, but frozen gases and grit and sand and dust in there. And as it melts, the dust is a white tail that curls behind the comet. So all of this looks like you might see a comet that's a fuzzy patch like that, and that's the dust tail, and you have that straight tail that's the gas tail. It's the solar wind that's pushing all of that material away. This dust falls in orbit behind the comet. The comet continues in orbit, it gets further away from the sun, it freezes back up, and that dust falls into orbit behind it. So there's a tube of dust that follows that comet around in orbit. And if we hit that tube of dust, then we get a meteor shower. And because our orbit intersects the orbit of a comet, there's the orbit of the comet, and there's our orbit, and we'll intersect it at the same time every year. Probably don't intersect it on this side because we're tilted. So we just, one part, we're not in the same plane, our orbits aren't. And so we hit this, we run into this tube of material. The Earth goes crashing through there at the 30 kilometers per second that the Earth is flying through space. And so we hit this tube of material, and we get meteors. Now, depending on where we hit this tube on any given year, we might see more meteors or fewer meteors in any shower that we happen to come across. And because we're hitting these in a particular spot, all of these meteors appear to come from the same point in the sky, and that point is called the radiant. And we name the meteor shower for the constellation in which the radiant resides. And so what we have coming up here this week is the Orionid meteor shower in Orion. So we have Orion, there's the belt of Orion, there's bright Betelgeuse, there's bright Rigel. Maybe you know Orion. If you don't, this is a chance to go out and learn the stars of Orion. But it's one of the more popular, well-known constellations there to say, okay, we've got the stars of Orion. We've drawn it on the board a few times. We've drawn it better than that on the board a few times, I do believe. So anyway, this is a chance to go out and learn those stars. If you don't, the radiant sits over here, and the radiant is the direction from which all the meteors will appear like they're coming. You don't have to look at Orion. In fact, it's probably better not to be looking at Orion, because the meteors could be way across the sky, and you trace back to look like this point where that's the point where our atmosphere is intercepting this tube of material. Now this is a relatively big, wide tube of material, so we're already doing it. The peak's going to be at the end of the week, the 20th, 21st, 22nd. Those might be your best time to go out and see these, but we're already hitting that, and we will continue for the next couple of weeks to have an enhanced rate of meteors. Now we're hitting stuff that's just randomly out there in space, and those random meteors, we'll see 5 or 10 of them an hour. Go outside any night, if it's dark, and you lie on your back and look at the whole sky, you'll probably see one every 10 minutes or so, 8 or 10 minutes, you'll see a meteor go by. But they're coming from this direction and that direction and whatever. These are all coming from this same spot. So you can tell the Orionids from the randoms by the direction. But there's another thing you could do. You know I like long-term projects for you, and here's a long-term project. Longish term, it's not really a long-term project, but just go out and start counting meteors. If you spend 2 hours a night out watching the sky, great. And if you do that, then you might count meteors and see what you see, and you might see that as we get to a meteor shower like this, we're expecting about 10 to 20 per hour of these meteors. once the radiant gets up into the sky. This region of the sky, for me, rises just after 10:30, 11. It doesn't get up into the sky where I could see it until 11:30 probably at night, each night here. And so after midnight, it will be high enough in the sky to be able to see this. By the time we get to morning, it's crossing the meridian, the north-south line. So it's just going to get better as the night goes on. Anywhere from about 11 o'clock at night until the sun comes up is the best time to see these meteors. But if you go back out to our project, you say, okay, I'm just going to count meteors and take notes. Say, okay, and over this last 3 weeks, I observed the sky for 5 hours, and I counted this many meteors. Now, during the meteor shower, observe the sky over this 3 hours and count meteors and see if you can see that that rate is higher. So kind of just keep track. You can watch over time, keep a journal, and note when you're seeing meteors and how many you're seeing per hour, and see if you can see this 10 to 20 per hour added to the 5 to 10 per hour of the random nightly meteors that you see. So maybe we're doubling or tripling our rate of meteors during the Orionid meteor shower. But you put those things together, and it suggests on the mornings of the 20th, 21st, 22nd, the moon should be scooted through the region, should be pretty dark. If it's clear, you have a chance to see a meteor every couple of minutes, every few minutes. That's pretty good if you've got good skies and get out there to do that. Now, Betelgeuse and Rigel are the bright stars. Let's use this opportunity to learn this region of the sky a little bit more too. So these are the bright stars of Orion that we typically draw on the board. But up above Orion, we have a couple of faint stars, a few faint stars, Mu, Nu, and Xi. And these stars are all fourth magnitude stars, so they're pretty faint. You can see them, no doubt about it. You got a good dark sky, but you don't see them all the time. So this is a chance. The radiant is over here by these. This is a chance to find these stars. So see if you can locate these stars. Alhena in Gemini. So that's in Gemini is the next bright star you come to up this direction. Something that's bright. Not as bright as Betelgeuse or Rigel by far, but much, much brighter than Nu and Xi, Orionis. So find that star up here. Now, also just near the radiant, just off Betelgeuse over this direction, and in the arm of Orion that's raised up this way, if you move over this direction about this much, you've got two so-so open star clusters. NGC 2244, and NGC 2264. They're both open star clusters, and in a small telescope or binoculars, you should see an enriched glittering of stars. They're not bad. It's fun to see them. It's fun to know these open star clusters. NGC 2244 has another characteristic with it. It's part of a system that contains the Rosette Nebula. So the Rosette Nebula is all around here, but this is a broad, faint, diffuse nebula. If you have a good pair of binoculars, you might be able to get a hint of this glow around here. In a telescope, it's probably just going to go and disappear on you because the surface brightness is so low. But you get a chance to see this nebulosity that is the Rosette Nebula around there. So give it a try. See if you can find these star clusters. These star clusters are in the constellation Monoceros. Not a constellation you probably know a lot about. A lot of people don't. It's the unicorn, Mono. So there you go. You've got the unicorn here, Monoceros, and so you have a chance to do a little bit of observing in this region by Orion this week. One more fun fact before we leave you here. This is stuff for you to do. Watch for enhanced meteor rate this week from the Orionid meteor shower. Enjoy Orion being in the sky at midnight and after. Learn some new stars maybe in Orion if you're not familiar with them. See if you can find the open star clusters in NGC 2244, 2264, and recognize that they're in a constellation you probably haven't spent a lot of time observing Monoceros. And that's all great, but let's leave you with one last thought. Remember, the meteor showers come from us intersecting a tube of material left by a comet, and this is left by the most famous comet of all, Comet Halley. And so now you think about the history of Comet Halley, and it's coming every 76 years, and some of you may have seen it when it was here in 1986. And so I did. And so there you go, and some of you may have something to look forward to see it the next time it's around. And so anyway, that's all ties together to have something fun to think about as you're out there observing and you're counting meteors and you're doing all of this. I hope you have a great week. I hope you have clear skies, and I hope you have a chance to get out and do a little bit of observing. It's a great time to be out and observing the sky. And we'll have something new for you next week. As always, thanks for watching, folks.